Hello everyone, and welcome to Chapter 10. In Chapter 10, we're going to be talking about the basics of confidence intervals. Things we're going to go over are introduction to estimation, confidence intervals for mu when the standard deviation is known, the sample size requirements, and the relationship between hypothesis testing and confidence intervals. So to begin, we're going to talk about the introduction to estimation. So remember, we've investigated the theoretical properties of a distribution of sample means, and now we're ready to take the next step and apply this knowledge to a process of statistical inference. Recall that our goal is to describe or estimate some characteristic of a continuous random variable, such as its mean, using the information contained in a sample of observations. So there's two methods of estimation that are commonly used. The first one is called point estimation. It involves using a sample data to collect a single number to estimate the parameters of interest. And the second is called the interval estimation. And this one is often preferred. It's a technique that provides a range of reasonable values that are intended to contain the parameters of interest, the population mean, mu, in this case with a certain degree of confidence. And this range of values is called a confidence interval. So like I said, two forms of estimation. Point estimate, the single best estimate of the parameters, x bar is the point estimate of mu, and the interval estimation is surrounding the point estimate with a margin of error that seeks to capture the parameters of a confidence interval. So here's a schematic of the confidence interval. As you can see, you have your point estimate or point estimate, and then it's plus or minus the margin of error. Plus minus the margin of error, and this gives you your upper and lower confidence limits. So the reasoning behind a 95% confidence interval, we have a schematic on the next slide of the sampling distribution of a mean based on repeated independent simple random samples of n equals 712. It's taken from a population with an unknown mu and a standard deviation of 40. Each sample derives a different point estimate and 95% confidence interval. 95% of the confidence intervals will capture the true value mu. So the whole point of a confidence interval is we're stating this is how confident we are that the true value of mu, when it's not known, is going to be in this range. And we're either going to be 90% confident, 95% confident, 99% confident that the true value of mu is captured in this interval. So kind of show you, so say you had a simple random sample, here's simple random sample 1, you have n equals 712, you're going to have x bar equals 1, and it's going to fall, so you could say this is x bar 1, this is your sample, sample mean, and then this is your 95% confidence interval. And then you have your simple random sample 2, and this could be your x bar 2, and then this is your x bar 3, and so on and so forth. And each one of these is representing 95% confidence of that sample. But that's the sample. Now remember, when we use mu, we're talking about the population. So we're using inferential statistics to gather information from a sample and infer it back to the population itself, right? And sometimes when we don't know a true value of mu sometimes, because maybe you're researching uncharted territory or there's just not enough information out there. So we have to derive from the samples an actual value of mu. And so you collect all your points, and then the true value of mu will be somewhere within, with 95% confidence in that range. So to create a 95% confidence interval for mu, you surround each sample mean with a margin of error notated as m. This is equal to two standard errors of the mean. So your margin of error is equal to 2 times your standard error of the mean. Or you can look at it as 2 times the standard deviation divided by the square root of n, which is your standard error. And the 95% confidence interval for mu is now x bar plus or minus the margin of error, right? So this would be for x bar is your sample plus or minus the margin of error, gives you the confidence interval, a 95% confidence interval of the true value of mu. So here's figure 10.2, 5 90% confidence intervals from a sampling distribution of X bars. The figure on the next slide shows the sampling distributions of the means. Below the sampling distributions are 5 confidence intervals. In this instance, all but the third confidence interval captures mu. So as you can see, here's your X bar 1, and here's your 95% confidence interval, and it's falling within the true value here. Like we said, the only one that doesn't is X bar 3. So here's its 95% confidence interval, but as you can see, that value falls outside the 95% area for the true population of the sampling distribution. And this is bound to happen, right? If you were to do this test 100 times, 5 of those intervals will probably not fall underneath this 95% distribution. We're saying that there's 5 of them out of the 100 that are not going to make it. You know, there's that 5% chance that they're not going to be there. So an example, a rough confidence interval. Suppose we have body weights of 10 to 29-year-old males that has an unknown mu but a standard deviation of 40. And you take a simple random sample of the 712 from this population and you calculate X bar to be 183. So how do you do your confidence interval at this point? So first we're going to figure out our standard error of X, which is equal to standard deviation over the square root of n. Standard deviation is 40 divided by the square root of 712, and you're going to get a value that equals 1.5. Your margin of error is equal to 2 times the standard error of X, which is equal to 2 times 1.5, which equals 3. So now we can say for a 95% confidence interval, CI confidence interval, for mu is equal to our X bar plus or minus the margin of error. We know our X bar is 183, plus or minus the margin of error, which is 3, gives you 180 to 186 pounds. So we are saying from the sample that we are 95% confident that the true value of mu of this population falls between 180 and 186 pounds. That is the rough confidence interval. I'm going to stop this video here. I'll pick up the last part of it in the next video. Once again, these videos are going to be very short. This chapter is very short, and it's going to go very quick, but it's very straightforward. So I'll pick up the next part going into a more accurate example of determining confidence intervals.